In this video I'm going to show how to make and install drag shafts. So drag shafts are these outboard shafts here. They're, like the name implies, used for drag. So one of the rules is ships must have scale number of shafts. So most World War I and World War II ships either had 2, 3, or 4 shafts, with majority having, especially World War II, 3 or 4. In order to get the boats to turn well, captains will power the most inboard shaft. So if it's a 3-shaft boat, they'll power just the center one, and if it's 4 shafts, they'll power the center 2. And that'll leave the 2 outboard ones as drag shafts. The rules also allow using a disc at the end of the shaft. So using the disc creates more resistance to flow. So when the boat is running the speed course, if there's more resistance along the hull, it'll need more thrust in order to counteract that resistance. And more thrust leads to more thrust over the rudders, which leads to better turning, which is why most captains will use a disc at the end of their drag shafts. Some captains prefer a more scale look, so they'll put a dummy prop on the shaft. This is showing on Missouri, which is a very big boat. General considerations for the drag shafts is making sure there's enough space between the powered shafts and the drag shafts. Typically these are discs, so if the disc was like very close to the prop, it would hurt the reverse thrust. It would block a lot of the reverse thrust. And then also want to keep it so it's not protruding too far beyond the profile, because the boats rub up against each other. So if you had a boat's bow like come through here, you want to keep it in as close as possible while also maximizing the size. Here's another example, drag shafts on Congo, and then this is more of my current method. The main components, you'll have the disc at the end. I'll put a threaded end of a screw to allow putting nuts on there to hold the disc on and change it out if necessary. You'll have the shaft itself, and then some sort of strut, and I'll use a piece of metal for that, because, like I alluded to before, these typically will stick out a little bit on boats, so you want something very strong there. I've certainly had non-metal struts broken by collisions. Here are materials. So I cut up discs. And then this will be for the South Dakota here. There's rules about the size of the discs. Current rules are whatever your powered drive props are, the disc can be up to a 1/4 inch additional in diameter. So I cut a disc. This is actually one of the windows from a recent build, but cut a disc. Pretty rough, but gets the job done. Other main parts are this tubing. I can get at some hardware stores, and I'll have different diameters. They'll all nest inside each other. So we'll have the main shaft portion, which will be something like this. I'll probably cut this in half because I don't need the length. And then these smaller pieces I'll cut up into little short pieces to pretty much make up the sleeve to go around the screws. In this case I have 632 thread screws, about an 1/8 inch diameter. So I'll use those. Typically I'd probably go a little bit longer. These are 1 inch, maybe 1 1/4. Not a huge deal. And then here's the metal pieces from the same manufacturer, K&S. And then I'll use this to make my struts, and I'll wrap it around the shaft. One of the first steps I'll do is determine where I want the disc to go. I'll do this in the first step because this will determine how long the shaft needs to go to get from the hull to the disc location. On this boat specifically, the stern doesn't really have a ton of room to fit a large disc. It's really just nature of the hull shape. Other hull shapes curve in closer to the waterline, and that'll leave more space underneath the stern to fit both the drive props and the drag props. So, as I said before, I don't want it too close. So, if I put it like right here, it would really hurt my reverse thrust. So, I think I'll end up around this area. But you can see here that with it going sort of up against that little notch there, there'd be a lot of the disc sticking out, which is not ideal. So what I'm thinking of doing, actually used an index card, and then I'm thinking of sort of cutting the disc like that, and then maybe putting it more like right there. So that'll leave some separation, and it'll sort of minimize how much of it sticks out. So I'll probably go like that. And then with this location, because of the hull shape, the shaft really won't need to be that long at all. So I'll just switch to a shaft, and then this is just a spare piece that I had. So something this long would be plenty long enough to get from the hull to where it is. So once I have that determined, next steps will be making the shaft. So you'll start with the tube for how long you want the actual shaft to be, and then I'll cut a bunch of little pieces which will make up the diameter between the shaft and the threaded portion. These are about a 1/2 inch long. Should be plenty. So I will cut those up. The next step is to solder the drag shaft together. So to do that, I've nested the shorter pieces together. See how they telescope together. I put flux on all the surfaces that'll help solder flow between them. I also put flux on the screw, and then I put a wrap of solder around the screw. So what I'll do is I'll compress these together, I'll put the screw in, and then I'll put it in the shaft, and then I'll cut up some more solder, drop it in the shaft, and then heat it with a micro torch to melt the solder and fuse it all together. Okay, see that together? Okay, and slide it in there. It's like that. And I'll take some solder and sort of twist it up. Drop it in there, and I will solder it. Okay, the solder just melted, so I'll look for it to seep out the bottom a little bit. Okay, so you can see it there. Okay, I'll let that cool off. Okay, this cooled off. This one actually came out really nice. You can see the solder at the end there. I'll use a Dremel to clean up the end of the stuffing tube there, and then I'll run a tap over the threads, rather a dye over the threads, just to clean them up. Alright, this is cleaned up and good to go. So this gives you a nice solid place to attach the drag shafts and put screws on. So next we'll be looking at the shaft and then the discs, and then identifying where to have it enter the hull, and then cutting the hull. I'll also make the struts once I determine that. I scoped out and marked where I think the best place for the shaft to go would be. So then kind of like that. And that should keep the profile generally within the confines of the hull. Sort of next steps is I will cut a hole right here for the shaft to go in. Things I want to look out for, make sure I don't cut into my actual drive shaft. Cut the slot for the shaft to go in, sort of line it up there. So I think this will be pretty good. Should be able to get it at a fairly level. Decent spacing between the props. Now if there's more room, I'd certainly want some more spacing, but this should be okay. So next step is, now that I sort of know, how far the end of the shaft is from the hull, I can make the struts. So I'm going to look and I'll measure it when I put the camera down, but it looks like it's about, I don't know, 1/2 inch to 3/4 of an inch from the hull. And that's how far the strut will have to go from the shaft. To make this strut, I started with this piece here. Generally I want to make sure it's long enough. Then I'll mark the middle. What I use a drill bit to bend it around. With this is relatively thin, so this will bend pretty easy. I use thicker material if I make struts for a drive shaft, and those ones certainly want to bend over something solid like a drill bit so you don't crush the shaft. So to do this, I'll just I'll put it on here, and I'll use like vice grips or something. Okay, so it's like that. And try to make sure it's perpendicular to the drill bit, and then I'll just use pliers, my hands really, to just sort of bend it around. You can see it's kind of like a U there, and then use some pliers, and then I'll shift the grip. Shift the grip to like that, and then finish bending the top in. Okay, so it looks like that. The pieces generally line up. They're a little off, not a huge deal. And then this will go over the shaft. I'll typically choose a diameter of drill bit slightly smaller than the shaft, so the shaft is 5/16 outer diameter, so this is a 64th, less than that, and then that sort of allows to sort of compress it a bit, and then this will be a nice strong mount that won't be subject to breaking. So now I'll sort of take this and identify where the strut needs to go, and then I'll mark it and drill a hole. Drill the hole for the strut and stuck it through. I'll typically just go up a little bit in diameter of whatever the strut width is. So this was a quarter, so I went up to 9/32. I'll sort of check the positioning, make sure it's a good location. It looks pretty good. I'll also typically flip the boat over, take a look at it. So now I'll go and I'll mark up the other side, and once I feel pretty good about it, I will plan to super glue it in place just to sort of hold it in the right location, and then I'll tape it up so I can fiberglass it in from the inside, similar to the drive shafts. Cut the holes for the drag shaft on the other side, and then flip the hull over just as a sanity check. So the angle in the shafts isn't too bad, relatively level. Sort of check from the stern. Looks pretty good. You can see they're generally within the profile of the hull. And then some level of separation with the drive props. You can see on the inside what it kind of looks like, so just outboard of the shaft. For the joint between the strut and the shaft, I'll use E6000. I'll use it because it's a pretty good adhesive. It's waterproof and sort of flexible, so I'll just put some on the shaft and then rotate the shaft around to make sure it's getting between the strut and the shaft. In some cases, just to get the shaft installed, you may have to rotate the shaft or the strut, or move the shaft or the strut relative to each other. Using E6000 is nice because it allows there to be flexibility in that joint until you get it in place, and then it'll set up pretty good. So now I will CA glue these in place so they're fixed when I go to epoxy them. Alright, I have the shafts in place. I will glue them in with the drag disc installed because that ensures that I'll be able to put the drag discs on the end of the shaft, and it is really easy standoff instead of making a separate jig like I did for the drive shafts. So now they're here. I'm going to check the periphery or to see if it fits within the profile. So I'll just this is straight up and down, and you can see that it's within. I'll check it on the other side as well, and then I'll just apply super glue to the strut joint and then the end of the shaft here, and that'll hold it in place. Shafts are super glued in place, so they won't move, which is good. Then I pulled the drag discs off because to tape this up especially around the strut joint here. It's typically pretty hard to get that sealed well. And then I'll tape over with electrical tape the hole penetrations as well, similar to what I did for the drive shafts. Taped the shaft holes up. For the struts, I use plumber's putty, which does a better job of getting between the two struts. Now from the inside, pretty much ready to epoxy. Probably just put some barriers up so epoxy doesn't run out, and then just fill it in with filler. The struts can stick up a little bit, that's fine. I'll let the epoxy dry, and then I can cut off any excess. For the drag shafts, I used epoxy to fill in on top. So I'll let this dry, and then remove the barriers, and it'll be done. The epoxy dried on the drag shafts, and I pulled the plumber's putty and the electrical tape off. As you can see, blends in quite nicely. That will about do it. So in summary, drag shafts are used to, like the name implies, give more drag to the ships, which requires more thrust for a given speed, which improves turning. There are multiple ways or styles that are common. This is the style I use. It's pretty quick to install. Other common styles will be installing just a normal shaft, or really just installing a normal stuffing tube with the shaft running through it, and then just use collars on the end. But that takes more parts than this, and I like the threaded end of this style. Hope this video was helpful. Thanks for watching.